Alright, welcome again in another tutorial of the topic differentiation. So in this tutorial we continue with Taylor's series. So in this tutorial we're going to see two examples that need the application of Taylor's series. So check out example 1 above. It says, what is the third term in the Taylor's expansion for tan inverse of x when a equals to 1. So our fx is just tan inverse of x, and our a is 1, okay? So this is the Taylor series, okay? So, but since our a is 1, then it will be f1 plus first derivative of f1 times x minus 1 plus second derivative of f1 over 2 factorial. Badala a tunaweka 1, x minus 1 squared, na kuendelea, right? So it's saying we should look for the third term. So this one is our first term, this one is our second term, and this one is our third term. So we are looking for this. So our third term now is just going to be equal to second derivative of f1 over 2 factorial times x minus 1 squared. So our fx, remember, is tan inverse x, okay? So nikidifferentiate tan inverse of x, napata 1 over 1 plus x squared, okay? You can see hii derivative kwenye ile tutorial nimetengeneza inaitwa derivative of inverse of trigonometric functions. So sasa hapa natafuta second derivative of f1, maana itabidi nitafute second derivative of fx. Maana kutumia concept of derivative of quotient of polynomials, angalia tutorial, nitapata ni sasa negative 2x over 1 plus x squared squared. But I'm looking for second derivative of f1. So manake ni kwenye hii, kwenye x nitaweka 1. It's just gonna be 2 times 1 over 1 plus 1 squared. Negative, okay? Never forget the negative. So it's gonna be negative 2 over 2 squared, which is just equal to negative 1 over 2. So this is my second derivative of f1. So my third term now, remember, is just equal to second derivative of f1 over 2 factorial times x minus 1 squared. Kwa second derivative of f1 tumepata negative 1 over 2 factorial times x minus 1 squared. So my third term is just negative 1 over 2 times 2 factorial times x minus 1 squared. So this is just equal to negative 1 over 2 times 2 factorial ni ngapi? Ni 2 times 1, okay? Times x minus 1 squared. So 2 times 2 is 4. Finally, my third term is just negative 1 over 4 times x minus 1 squared. So alisema what is the third term in the Taylor's expansion? Ndo hiyo sasa. So that is example 1. So let us see example 2. It says use Taylor's series to expand here in ascending powers of k as far as the term containing k power 3. So hapa, remember kwenye ile video tutorial iliyopita ya Taylor series, nili represent two kinds of Taylor's expansion. Ya kwanza ilikuwa ni fx, ya pili ilikuwa ni fa plus h, ambao tukasema ukiexpand hii by Taylor's expansion sana useme fa plus f dash a, yani first derivative of a, h plus f dash dash a over 2 factorial h squared plus f triple dash maana third derivative of fa over 3 factorial h cube na kuendelea. So this time kwenye swali letu hatuna sin x, tuna sin pi over 6 plus k. So kama mazingira haya we prefer to use this Taylor's expansion where our a is equal to pi over 6 and our h is equal to k. So now if I expand, so in that case, so my f now is just like pi over 6 plus k. It's just going to be f of pi over 6 plus f dash of pi over 6 times k sasa, okay? Make times h, so it times k plus f second derivative now of pi over 6 over 2 factorial times k squared plus, sasa amesema to expand mpaka takapofika k power 3. Kwa hiyo ya mwisho kwenye expansion yetu itakuwa ni hiyo pi over 6 k power 3 over 3 factorial. So nikiendelea ni k power 4, lakini ametaka to expand mpaka takapofika kwenye k power 3. So now nitafuta hizi f pi over 6, okay? So f pi over 6 manake itakuwa ni sin pi over 6, okay? Kwa sababu hii f pi over 6 plus k, okay, ndio hiyo sin pi over 6 plus k, alright? Tunayo expand. So nikitafuta f pi over 6 maana naondoa k na baki na pi over 6 peke yake. So first derivative sasa ya huyo mwamba ukidifferentiate sign unapata nini? Cos pi over 6. Second derivative je, maana ita differentiate hiyo cos, utapata negative sin pi over 6. Na third derivative sasa ya huyo pi over 6, maana ita differentiate negative sin, utapata negative cos pi over 6. So pi over 6 in radian, we convert into degrees sasa na 30 degrees. So sin of 30 degrees is half. Okay? Cos of 30 degrees ni radical 3 over 2. Hapa sin of 30 degrees kuna hii negative pia, negative half. Na hapa nitakuwa ni negative radical 3 over 2. So hii sasa naipachika hapa. Hii naipachika hapa. Hii naipachika kwenye hapa f dash dash pi over 6, na hii naipachika hapa kwenye e triple dash. So my sign now pi over 6 plus k is just going to be equal to 1 over 2 plus radical 3 over 2 times k minus 1 over 2 factorial times k squared plus, minus again is negative 3 over 2 over 3 factorial times k cube. So naishia hapa kwa sababu amesema ni expand mpaka k power 3. So this is just 1 over 2 plus radical 3 over 2k minus, it's going to be 1 over 4k squared, okay? Kumbuka 2 factorial is just 2. 3 factorial is 6, okay? Kwa sababu 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. So itakuwa ni minus radical 3, 6 times 2 is 12, k power 3. So finally now, my sin pi over 6 plus k, okay, expand mpaka ufike k power 3, itakuwa ni 1 over 2 plus radical 3 over 2k minus 1 over 4k squared minus radical 3 over 12k cube. So this is our final answer. You can see nimeexpand mpaka nimefika kwenye k power 3. So this is my final answer. So let me just say, see you in the next tutorial where we shall cover Maclaurin series.